What we did in chapter 5 you need for chapter 6, and anything we didn't cover from chapter 5 we will cover in chapter 6. So you're going to solve for missing function values or angles using inverse circular functions. So they're going to actually talk about the inverse of your trig functions. Inverse functions, if a function is one-to-one, then the inverse is also a function. One-to-one functions, each x value corresponds to exactly one y value, and each y value corresponds to exactly one x value. So your x's cannot repeat, your y values cannot repeat. One-to-one functions, a function is one-to-one if it passes the horizontal line test. So this one here would be considered one-to-one. Because any horizontal line, it only crosses the graph once. This one, however, is not one-to-one, because of this any given horizontal line test, it would hit the graph twice. Okay, so the quick little test. Vertical line test is to determine if it's a function. Horizontal line test is to determine if it's one-to-one. Okay. Finding the inverse of a function that is not one-to-one. To do so, we must restrict the domain of the function to make it to appear to be one-to-one. So as in x squared, the original domain is negative infinity to infinity. All values can be taken. But on this one here, your new domain, if you restrict it here so that we can do the horizontal line test, it's now 0 to infinity. If they tell you to restrict it, always restrict it on the positive side if you can. Okay, so notice our trig function that our y values consistently repeat. So we will have to fix the domain, or the range in this case. So we must first restrict the domain from negative pi over 2 to pi over 2 to make it one-to-one. So on this one, what they're looking at is from negative pi over 2, if you're at your minimum, all the way to the maximum. We couldn't start it here because, one, we don't have any of our negative values, and two, it's not one-to-one. But if we start from here to here, we can see that nowhere in there does it repeat, and we're getting all of our values in here. So there's the graph that they restricted it to. So they want you to make a table of values for this portion of the sine graph. So we're going to do pi over 2, negative pi over 4, 0, and then positive pi over 4. Our sine value here is negative radical 2 over 2. This one is 0, and this one is positive radical 2 over 2. And you can see that we're hitting all of our positive and negative values for sine. To find the inverse of y equals sine x, we need to interchange our x and y values. So what we had done up there, all of our x and y values, our y values are now going to be our x values. So we have negative 1, negative radical 2 over 2, 0, radical 2 over 2, and positive 1. And then this is going to become negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. We can also graph it over here. Negative 1, negative radical 2 over 2 is about 0.70, so more like 3/4 than a half. Same thing over here, positive 1, and then the other would be there. And of course, we have a 0, 0. Pi over 4, pi over 2, negative pi over 4, negative pi over 2. So negative 1 is at negative pi over 2. Negative radical 2 over 2 is pi over 4. 0, 0. These guys go here, and these guys will go here. So we're going to get a graph that's going to look something like that. Okay, it should be more rounded kind of thing. But I think you guys get an idea. This is what we're looking at. We've been playing with these already. So I do want to point that out. We have been playing with those. Okay. Same thing with cosine. Notice we got things going on here, but if we wanted just positive and negative values, we're going to go 0 to pi. So just like the last one, they're asking you to write them in there. 0, pi over 4, pi over 2, 3 pi over 4, and then pi. Now we could have done the pi over 3s, the pi over 6s, but as 0, the cosine value is 1, radical 2 over 2, 0, negative radical 2 over 2, negative 1. And just like before, we would change the x and y values. So I'm going to go ahead and pause this, put those in, and then give it to you so we're not taking a precious video time. You can just pause it as well and write things in. Okay, so you can see where I changed the table for cosine, arc cosine, my values, and then my angles, and then the graph. You can see where the graph is taking. And that's where you have there. Okay, and then tangent, looking at the inverse for a tangent, all of the values do this bit, and our domains are already restricted, negative pi over 2 to pi over 2 kind of thing. There it is all restricted in there, that little bit. And notice there the values are for your y values here. That would be the same for cosine or cotangent as the tangent would be. Okay, now this table is, if they don't give you a specific area, if they don't say within this interval, then this is what they're looking at. So all of your sine values will have a domain between -1 and 1, and that's the interval you grab things from. Quadrants from the unit circle, you're looking at 1 and 4. Cosine, again, -1 to 1, 0 to pi, you're looking at quadrants 1 and 2. That's going to give you all the positive and negatives. Tangent, again, 1 and 4. Domain is all numbers. The interval is negative pi over 2 to pi over 2. So again, quadrants 1 and 4. Because we don't want to jump over a one of the asymptotes. Same with cotangent, 0 to pi, so you're looking at quadrants 1 and 2. Secant, just like cosine, 1 and 2, and so forth. So evaluating with your inverse functions, if you have y equals arc sine of x, then we say y is the number in the interval whose sine is x. You can rewrite it at y equals arc sine of x as sine of y equals x. Be careful with the domain and range values. I've always told you guys that when you see this arc sine of x, that you use what angle has a sine value of, what angle has a cosine value of, and then you look at the interval in which they're asking you to find it in. So on this one here, okay, so they're looking at here, give the angle, find the value of the function, given the function, find the measure of the angle. So y equals sine of x, 30, the y sine value is 1/2. But they say y equals arc sine of 1/2, you're going to give the 30-degree angle. Cosine at 45, radical 2 over 2, quadrant 1. Arc cosine radical 2 over 2 is still quadrant 1, and it's radical 2 over 2. Whoops, outside. Try again. It's a 45-degree angle. And then tangent of 135. Tangent 135 is -1. we're in quadrant 2. And according to that chart we were just looking at, when they have arctangent, they want you to grab quadrant 2, which would be 135 degrees. No, tangent, they want you to grab quadrant 4. It'll be quadrant 4 according to that chart. So it's 315 degrees. Again, when you come to your arctangents, they do not want you to go past a asymptote. Okay, so using your unit circle, that's all we're going to do. So arc cosine, if it's negative, they want you in quadrant 4. But if you were in quadrant 1, so your reference angle, basically your reference angle would be just the radical 3 over 2, which gives you a 60-degree angle. But in quadrant 4, 360 minus 300, I'm doing the math in my head and giving you the answer before I'm going to get there. 360 minus 60 gives you 300 degrees. Okay, arctangent at 1. So we're looking for the angle in quadrant 1, which is going to be 45 degrees. And the last one, arc cosecant of radical 2. So we can also change this to arc sine of radical 2 over 2. We're in quadrant 1, and this would be a 45-degree angle. Remember, you're looking at the chart because they're not giving us intervals within the look, so we have to go off the chart. If they give us the intervals within the look, we go by that. Okay, so give the degree measure of theta. Do not use a calculator, which means you're using your unit circle, or if you have this memorized, you're going to use your memorization. So this one is the angle whose arc, so the angle whose cosine value is -1/2. Well, 1/2 theta would be 60 degrees. But this is in quadrant 2. So we would do 180 minus 60 degrees, which is going to give you 120 degrees. Same with this one, cosecant follows sine. So since reciprocal of -1 is -1, I can rewrite it as arc sine at -1. And they tell us to look in quadrant 4, but this is a quadrantal angle. So we're either at pi over 2 or -pi over 2, but the one that gives us -1 is this guy. Okay, it's reading your unit circle. Just remember, anytime you see this, you're looking for an angle. So the angle whose cosecant value is -1. Okay, so the next one's asking you to use a calculator. So on this one, you're going to put it in there. So what buttons do you push? Second, cosine, and then you put in the values. -0.133488816. Make sure your calculator is in degree mode, and they give you theta equals 97.671 degrees. So the next one, how to put this one in the calculator. Since we do not have cotangent on your calculator, we have to play with this a little bit. So this is arc cotangent of 1.7670492. So reciprocal cotangent is tangent, so arc tangent and then put it in the calculator as 1 over 1.7670492, or do the arctangent of 1.7670492 to the negative 1 power. This is one of those, this is not an angle. So if you take the reciprocal of the trig function, you take the reciprocal of the trig value. Okay, so either way, you want to write that in into your calculator. But either way, then this one, your theta value becomes 29.506 degrees. And last one, they gave you a cotangent again. So arctangent of 1 over negative 2.77, getting carried away, 277.33744, or arctangent negative 2.773744 to the negative 1. Either way, theta becomes 19.8278 degrees. Okay, another one, secant. Again, secant is not on the calculator. The reciprocal of secant is cosine. So I'll do arc cosine, same thing. 1 over negative 1.28716844, or arc cosine negative 1.28716844. Either way, theta becomes 140.9775 degrees. Ooh, I just saw this, and I need to point this out. Real number, when they say real number value, they mean radians. So this is one of those that we get to do this. If you forget to change it from degrees to radians, we just convert this guy. So we're going to convert him. So change this to radians by multiplying by pi over 180. So theta equals, or in this case, y equals 2.4605. No degree symbol or anything like that. Just leave it like this. Okay, now this is one not to get thrown off on. We've done these before. I want the sine value of the angle who has a cosine value of 1 over 4. So let's write that out. You want the sine value of the angle with a cosine value of 1 over 4. Not so bad. We've done these before. X equals 1, y we don't know, and r is 4. And we use Pythagoras' theorem. We can. The idea of x squared plus y squared equals r squared. R is always positive. So 1 plus y squared equals 16. Yes, I skipped steps. 1 squared is 1, 4 squared is 16. Subtract 1, subtract 1. So y squared equals 15. So y equals plus or minus the square root of 15. Now, if they don't tell you which quadrant you're looking for, positive, negative, angle kind of thing, we can, well, actually, we go like this. Cosine is positive. And when we're doing arc sine, arc cosine, only time sine and cosine are both positive is when cosine is when we're in quadrant 1. So we're going to assume we're in quadrant 1 rather than quadrant 4 because we don't know if the x value is positive or negative. So on this one here, it's not so much that you need to find out what this angle is. We do not need to find out the angle. The thing is they told you the cosine value. You want the sine value. So you're using this. So if we're in quadrant 1, then it's going to be, it's plus or minus. If we're in quadrant 1, it's going to be square root of 15 over 4. And if we're in quadrant 4, where cosine is also positive, it's going to be negative square root of 15 over 4. We don't know which quadrant we're in, so give both answers. Okay, so this one here, now this one, because they're telling you that this is negative, we know we're in quadrant 4. Now, if you're sitting there going, wait, how do I know? Because unless they tell you otherwise, we are looking at, for sine, quadrants 1 or 4. It's negative, goes to quadrant 4. Secant in that case will be positive. It's the same thing. I want the secant value of the angle whose sine value is negative 1 over 5. So we go for x equals, y equals negative 1, and r equals 5, because r is always positive. X squared plus y squared equals r squared. We don't know x. Negative 1 squared is 1, and 5 squared is 25. So x squared equals 24. So x equals plus or minus square root of 24. But because we are in quadrant 4, we know the x value is positive. So this is going to be square root of 24 or 2 square root of 6. 24. Let's break it down. 4 times 6. Perfect square. So your secant value is r over x, which gives you 5 over 2 square root of 6, which is going to be 5 square root of 6 over 12. There is your value. Okay, this is going really, really long. So I think we're going to stop the video here. I'm going to pause it for just a second so you can see what the homework is going to start to be, so you can start it if you want to. But do get started on the homework. Okay, I am only going to throw this as one assignment, so that is your one assignment. So you'll turn them all in together. It just gives you the opportunity to start on it if you wanted to. Okay, good luck.